In the last period, we have seen the concept of moment of inertia and the radius of gyration. Today, we will see the kinetic energy of a rotating body. Consider a rigid body of any size and shape. It is not necessary that this body should be in a geometric size. We have taken a rigid body of any size and shape. Let this rigid body consist of n particles of masses m1, m2, m3, mn, and their distances from the axis of rotation are r1, r2 and r3 rn respectively. Let this rigid body is rotating about the given axis of rotation xy with constant angular velocity omega. So its speed of revolution is constant. And v1, v2, v3 and vn will be the velocities of the particle, n particles respectively. So see the description of this figure. This rigid body consists of n particles of masses m1, m2, m3 mn, and their distances from the axis of rotation are r1, r2, r3, rn respectively. Let this body is rotating with constant angular velocity omega about the given axis of rotation xy, and the linear velocities of n particles are v1, v2, v3, vn respectively. Then we will see the kinetic energy of a first particle. So kinetic energy with the first particle, kinetic energy is 1 by 2 mass into velocity square. So kinetic energy with the first particle is 1 by 2 into mass of first particle into velocity square. That is a v1 square, velocity of a first particle. But v1 is equal to r1 omega. Velocity is equal to radius into angular velocity. If we square this, v1 square is equal to r1 square omega square. Substitute this value of v1 square in equation 1. After substituting this value in equation 1, kinetic energy with the first particle Ke1 will be 1 by 2 m1 r1 omega square. Similarly, in the same way, kinetic energy with the second particle Ke2 is equal to 1 by 2 m2 r2 square omega square. फक्त त्या ठिकाणी पार्टिकलचं जे मास आहे ते m1 m2 चेंज होतं, डिस्टन्सेस r1 r2 चेंज होतं आणि ओमेगा कॉन्स्टंट राहतं. कायनेटिक एनर्जी विथ द थर्ड पार्टिकल इज 1 by 2 m3 r3 square omega square, and in the same way kinetic energy associated with nth particle, that is nth particle here, that is 1 by 2 mn rn square omega square. In this way, we have calculated the kinetic energy of n particles. As kinetic energy is a scalar quantity, to find the total kinetic energy, we will take just algebraic sum of all these kinetic energies. So, total kinetic energy of a rotating body. Total kinetic energy of a rotating body will be the algebraic sum of all kinetic energies, that is a Ke1 plus a Ke2 plus a Ke3 plus and so on up to Ken. In this way, we have added all kinetic energies. We will substitute the values from above equation. So total kinetic energy is equal to KE1. Value of KE1 is 1 by 2 M1 R1 square omega square. Instead of KE2, 1 by 2 M2 R2 square omega square. Instead of kinetic energy of a third particle KE3, 1 by 2 M3 R3 square omega square. And so on, plus 1 by 2 mn rn square omega square. So this is the kinetic energy of the nth particle. From this equation, we have taken a common 1 by 2 and omega square. Because omega for each particle is one and the same, therefore we have taken a common 1 by 2 and ओमेगा स्क्वेअर आणि 1 by 2 कॉमन घेतला, 1 by 2 इथं लिहिला, ओमेगा स्क्वेअर इथं लिहिला, ब्रॅकेटमध्ये काय शिल्लक राहील, m1 r1 स्क्वेअर प्लस m2 r2 स्क्वेअर प्लस m3 r3 स्क्वेअर प्लस and so on up to plus mn rn square. But this m1 r1 square plus m2 r2 square plus m3 r3 square plus so on up to mn rn square is equal to I, where I is the moment of inertia of a rigid body about the given axis of rotation. या axis of rotation भोवती याचा moment of inertia I आहे. So this bracket is equal to I, which is moment of inertia, where I is the mi of a body about a given axis of rotation. So if we substitute this value in above equation, then the kinetic energy of a rotating body is equal to 1 by 2I omega square. So this is the kinetic energy of a rotating body. If a question is asked further to define the moment of inertia, hence define moment of inertia, then we have to state the definition of moment of inertia I from this formula only. That is, kinetic energy is equal to 1 by 2I omega square and I is equal to 2 into kinetic energy upon omega square. If omega is equal to 1 radian, then moment of inertia is equal to twice the kinetic energy. Means moment of inertia is defined as it is the kinetic energy twice the kinetic energy possessed by the body when it rotates with unit angular velocity. See the definition of moment of inertia. Moment of inertia is defined as it is twice the kinetic energy possessed by the body when it rotates with unit angular velocity. So this is the expression for kinetic energy of a rotating body. After kinetic energy of a rotating body, we will see an expression for torque acting on a body. What is the expression for torque acting on a body? Torque is analogous to force. The role of force and the role of torque is one and the same. Here, consider a rigid body of any size and shape. And this rigid body consists of n particles of masses m1, m2, m3, dash dash mn. And their distances from the axis of rotation are r1, r2, r3, rn respectively. Let this rigid body is rotating about the given axis of rotation with a constant angular velocity. This is xy is the axis of rotation. About this axis of rotation, the body rotates with constant angular velocity. या बॉडीची रोटेट होण्याची जी अँग्युलर व्हेलॉसिटी आहे ती कॉन्स्टंट आहे. And these n particles are moving with linear accelerations a1, a2, a3, an, and the forces acting on the particles are F1, F2, F3, F4, Fn respectively. So, see this. What are the forces and accelerations of the particles and masses of the particles? So, I will repeat once more. This is a rigid body which consists of n particles of masses m1, m2, m3, dash dash mn, and their distances from the axis of rotation are r1, r2, r3, dash dash rn respectively. This rigid body is rotating with constant angular velocity about the given axis of rotation, and these particles, n particles, they are moving with acceleration a1, a2, a3, dash dash an respectively, and the forces acting on the particles are F1, F2, F3 and Fn respectively. So this is the description of this figure. After that description, we will calculate the torque acting on the first particle. Torque is the cross product of length of moment arm and force. As this is a first particle, length of moment of arm is r1 and force is F1. So torque τ1 is equal to torque acting on the first particle is the cross product of length of moment arm, that is r1, and force acting F1. So torque acting on first particle is equal to r1 F1. If we take the magnitude of the torque, τ1 is equal to Ref sine theta. So this is the scalar form. But theta is equal to 90 degree. Why theta is equal to 90 degree? So this length of moment arm, that is a radius vector r1 and F1, they are perpendicular to each other. So theta is equal to 90 degree. Angle between r1 and F1 is 90 degree. So theta is equal to 90 degree, sine 90 is equal to 1. Therefore, this equation, torque acting on the first particle, τ1 is equal to r1 F1. Sine theta becomes 1. But F1 is equal to, according to Newton's second law of motion, force is equal to mass into acceleration. F1 is equal to m1 a1, but a1 acceleration, linear acceleration is equal to r alpha. So a1 is equal to r1 alpha. A1 is equal to, that is a acceleration of a first particle if it is expressed in terms of angular acceleration, then a1 is equal to r1 alpha. So this equation τ1 is equal to m1 r1 alpha. So this equation F1 is equal to m1 r1 alpha. If we substitute the value of F1 in this equation, then τ1 is equal to r1 into F1. F1 means m1 r1 alpha is equal to m1 r1 square alpha. So this is the equation for torque acting on the first particle. As we have calculated the torque acting on first particle, easily we can write the equations for torque acting on second particle, third particle, fourth particle and nth particle. So similarly, torque acting on second particle is equal to, pattern of the equation is the same. Instead of m1, m2, instead of r1, r2, that is m2 r2 square alpha. m2 r2 square alpha. Similarly, the torque acting on third particle m3 r3 square alpha. And so similarly we can write the equation for nth particle. Torque acting on nth particle is equal to mn rn square alpha. So the total torque acting on a body is the sum of all torques which are acting on the particles. So total torque is equal to τ1 plus τ2 plus τ3 plus and so on up to plus τn. That is a torque acting on nth particle. So we have taken the summation of all torques which are acting from first particle to nth particle. So substitute the value of τ1 is equal to m1 r1 square alpha plus τ2 is equal to m2 r2 square alpha plus τ3 is equal to m3 r3 square into alpha plus and so on up to plus mn rn square alpha. So this is the torque acting on the nth particle. In all terms, alpha is the same. So we have taken the common alpha. Then what will be in bracket? m1 square r1 square, as alpha is taken common. As alpha is taken common, m2 r2 square plus m3 r3 square plus and so on up to plus mn rn square. But sum of m1 r1 square plus m2 r2 square plus m3 r3 square plus and so on up to plus mn rn square is nothing but it is the sum of product of mass of the each particle and the square of its distance from the axis of rotation, and it is called as a moment of inertia. So this term is equal to I, where I is the moment of inertia about the given axis of rotation. So the torque acting on a body τ is equal to I alpha. If we substitute this value of I in above equation, then torque acting on a body will be I alpha. In this way, we have obtained an expression from torque acting on a body. From this expression, if the definition of moment of inertia is asked, from this definition, if the question is like that, obtain an expression for torque acting on a body, hence define mi. याचा अर्थ असा होतो की या डेफिनेशन पासूनच तुम्हाला मोमेंट ऑफ इनर्शिया डिफाइन करायचा आहे. सो हियर I is equal to τ by alpha. So moment of inertia is defined as torque per unit angular acceleration. If this body is rotating about the given axis of rotation with unit angular acceleration न रोटेट होत असेल तर त्या बॉडीवर ऍक्ट होणारा नेसेसरी टॉर्क हा त्या बॉडीच्या मोमेंट ऑफ इनर्शिया इतका असतो. या ठिकाणी तुम्ही ओरिजिनल मोमेंट ऑफ इनर्शियाची जर डेफिनेशन लिहिलात तर मार्क मिळत नाही. हेन्स डिफाइन mi म्हणल्यानंतर आलेल्या एक्सप्रेशन पासूनच मोमेंट ऑफ इनर्शियाची डेफिनेशन लिहावी लागते. आणि ती डेफिनेशन काय? इट इज अ टॉर्क पर युनिट अँगुलर ॲक्सलरेशन. ओके.